We're looking at a review of linear regression. I give you an example of the sale price of 10 houses and their size in square feet for a given town. Okay, so X is the square feet and Y is the house price in thousands of dollars. So number one, create a scatter plot on your calculator and find the linear regression model. Round coefficients to the nearest hundredth. Okay, so in your calculator, that's where you press your stat and then enter to edit your list. For the sake of time, I already have these in here, so if you need to pause the video, go ahead. I'm just going to keep on going. So you put list 1 is your X values, list 2 is your house price or the Y values. So to create the scatter plot, you go to second Y equals to make sure your plot is on. Okay, press enter. I'll turn my plot 1 on. Okay, the first type is your scatter plot. And then my values are in list 1 and list 2. Okay, so make sure you do second 1 for the X list and second 2 for list 2 for the Y list. Okay, and then the mark just shows you how they're going to show up on the scatter plot. Then if I do zoom 9, I get the scatter plot. It does appear that there's a positive correlation between house price and square feet. Okay, so now what we'll do is we'll calculate the linear regression model. So stat, calculate down to lin reg. Now you can use ax plus b or a plus bx. Either one works. Just make sure you keep the variable straight. I'll use a plus bx. Okay, on list 1, comma, list 2. Your operating system may be a little bit different. Just make sure that you put your list 1 and list 2 as the correct variables for your X and Y. Okay, press enter. And here I get A is 98.248. So to the nearest hundredth, that's 98.25. That is the A value, or the Y-intercept in this case. And 0.10976. So to the nearest hundredth, that B value is 0.11. Okay, so in this case, B is the slope, because it's the coefficient of X. And the R value is 0.762. That's the correlation coefficient. Okay, so to write our equation, rounding to the nearest tenth, okay, we have y hat, that's your predicted value, is 0.11x plus 98.25. Excuse me. And then we find the value of the correlation coefficient, that's R, is 0.762, which we already found that in our calculator. And remember in the other videos I showed you if that doesn't show up, you have to go to second catalog and scroll down to diagnostics on to turn your diagnostics on. Refer to my regression video if you don't know what I'm talking about. Okay, so the value of R is 0.762. And what that tells us is there's a fairly strong positive linear correlation between house price and square footage. Okay, so to explain the value of R, you always want to use the words like strong or weak, positive or negative, and yet it's a linear correlation. Okay, so those are the few things that you highlight when you describe R. As far as the slope of the regression model, okay, what the slope is 0.11. And that tells you how much the Y value, or the house price, is increasing by per square foot. Okay, so in terms of the problem, we predict the house price to increase by $0.11,000 for every 1 square foot in additional size. Now, $0.11,000, you could also write that as $110. Okay, number 4, the y-intercept. So that's 0, 98.25. And we'd be saying that a house with 0 square feet, okay, so that's X, to have a price, the Y, of $98.25 thousand. Now, we may not be able to have a house with 0 square feet, but that's what it would mean. Okay, which just tells you that you don't want to, as with any linear regression, you don't want to go too far outside of the values you were given in your table, or else your model may not be accurate. Okay, then use your model to predict the house price that is 2,000 square feet, and then in number 6, use your model to determine the number of square feet in a house for $250,000. Okay, so that's just using your two equations, where 2,000 in number 5, 2,000 is your X value, and 250 is your Y hat value in number 6. Just go through and solve those two equations. Okay, so that's a quick review of linear regression.